People ask me about NC2 on AWS constantly, and one question that keeps coming up more than any other is once your VMs are up and running, where does that traffic actually go? Diagrams leave out the most important part that matters. So here's the real path, traced start to finish. Nutanix Cloud Clusters NC2 puts a full Nutanix stack on bare metal servers inside your own AWS account. Turn on Flow Virtual Networking and your VMs stop sitting on AWS's native network. They move on to an overlay instead, and that raises one real question. When a VM needs to reach anything outside that overlay, where does the traffic actually go? Start with what AWS sees, one real AWS VPC holding the bare metal EC2 hosts running AHV and the controller VMs, plus a public subnet with an internet gateway and NAT gateway that keep the cluster manageable. Turn on Flow Virtual Networking and deployment adds two subnets, one for Prism Central, one for FVN. The FVN subnet attaches to every bare metal node, and it's what supplies the gateway ENI, the SNAT IPs, and the floating IPs, not a separate box in the transit VPC. The first cluster you deploy with FVN auto creates a Nutanix transit VPC, the on-ramp between the overlay world and the real AWS world. Your VMs don't live there. They live in a user VPC in overlay subnets with their own private ranges, and each user VPC connects to the Nutanix transit VPC for anything beyond itself. Attach a NAT external subnet to a user VPC, and outbound traffic gets simple. A VM sends a packet out. The VPC's route table sends it to the transit VPC's NAT subnet. A Nutanix NAT gateway function running right on one of the cluster's own bare metal hosts swaps the VM's private overlay address for a shared SNAT IP, an address that's already a real routable member of the AWS VPC. From there, the packet looks like any other AWS native traffic. It exits through the same internet gateway any EC2 instance would use. No-NAT solves a different problem, direct reachability inside your AWS account or a peered network, not general internet browsing. Here, the VM keeps its real overlay IP. Instead of translating it, you declare that address range as an externally routable prefix, once on the Nutanix Transit VPC and once on the User VPC. The ERP rides a routed lane, not the SNAT pool. Once it's set, AWS's own VPC route table gets a new entry. That prefix pointed at that VPC's gateway ENI, which can sit on a different node per VPC. The VM's actual address becomes routable inside AWS, no disguise, no translation. Reaching anything outside the AWS account, like a private data center, still rides an AWS transit gateway, not the Nutanix transit VPC. Now flip it around, because inbound traffic behaves completely differently depending on which path you picked. On the NAT side, nobody outside can reach a VM's real IP. It was never advertised anywhere. So you request a floating IP from that same NAT subnets pool and assign it to the VM. Inbound connections hit the floating IP, and the gateway translates it back to the VM's private address. On the no-NAT side, there's no floating IP step. AWS's route table already points that VM's prefix at the gateway ENI, so inbound traffic addressed to the VM's own IP lands on the transit VPC's no-NAT external subnet, not the NAT pool. From there, it gets routed, not passed through untouched. Flow Virtual Networking uses the gateway's host as the redirect chassis for AHV. The transit VPC steers the packet to whichever node is running the target VM, then hands it onto the overlay. The VM's real IP is preserved end-to-end. Nothing gets translated, but the packet is still routed to the right host. Same cluster, same overlay, two traffic choices. NAT hides the VM behind a shared poolable address, and every inbound connection costs you a floating IP. No-NAT puts the VM's real IP directly into AWS's own routing with nothing translated, but it asks you to plan your address space like you mean it. Pick the routing option that fits the workload. That's the whole decision, really. Get the routing right and everything downstream, security groups, monitoring costs, get a lot simpler. If you're deploying this yourself, reach out. or follow along for more NC2 deep dives. We'll see you in the next video, and good luck with your build.